And hello, everybody. Today, we are going to work on a really important part of how lenses work. We're going to be talking about magnification. Specifically, if you have a spectacle lens, how much does it magnify? And it's actually more complicated than what when we originally taught you early on. We always said plus lenses magnify, minus lenses minify. Off you go to the races. Well, obviously that's sort of the layman's term and the really simplistic. But now we get into the more specifics of it's not just the power that makes a difference, it's how did we make it? And there are a handful of categories or a handful of properties of a lens that will affect its magnification. So one of them is its material, one of them is its base curve, one of them is how far away it is from the eye, and the last one is its center thickness. There are four aspects. Now, instead of memorizing it, instead of just sort of telling it to you, we have another episode or another sort of resource for you to work on and sort of get your mind around this and try almost like a virtual hands-on component to that. So I do like OptiCampus. Let me share this real quick. We share this here, and we're sharing this now. Here's our Blackboard. I'll come back to that. But there's one of the sites that I really like. It's OptiCampus right here. And they have a whole host of calculators, which are great. And lens tilt wrap compensation, cross cylinders, vertex, you get it. But here's a spectacle magnification in sphere, cylinder, axis. Well, here I can only do one lens at a time. So we're not going to use that, but this is a valuable one for you to get a basic idea. But what I'm going to do today is if we go into our Blackboard and spectacle magnification, we're going to open this up, and I'm going to give you some exercises to see what this looks like. And if we bring this over, this is the worksheet that I've developed. And now, just as an aside, like we said in our lecture, there are two things that will determine if a lens magnifies or minifies. And the first part is its power. Obviously, if it's a plus lens, if it's a minus lens, it's going to have some type of magnification or minification that's based on not just the power, but also its vertex distance. If closer or farther away, it's going to affect it. But there's also a component that we sometimes ignore, especially if we're looking at things at a very basic rudimentary level. But there's also a big consideration about thickness and the power and the index of refraction, T1 and N. Actually, technically, it's the be that as it may. So in our time, back in the day, I would have given you these formulae, and I'd have made you crunch stuff and holler at it and come up with it and spend times just numbing, like getting your pencil lead all dull. And I don't want to do that because if you're so busy trying to plug stuff in, if you do it wrong, it doesn't work. If you spend more time crunching numbers and less time understanding what it all means, it doesn't do us any favors. So what I have here is a little tool that we've developed. And what we do is we add in the right eye. If I had a pair of glasses, this is pair number one. I have the right eye and the left eye, and I have two lenses. I can actually take a look at what properties of each lens we're going to enter: thickness, index of refraction, the base curve, the vertex distance between the glasses, and the power of the lens. We're referring to the back vertex power. So adding 2.1, let's say it's a 2.0 center, CR39. Let's do this. There we go. 2.0 and lens thickness of 2.0 millimeter center, which this is cool because what I did was this formula you need to have to make sure that the thickness is in meters. Well, I don't want you to, you are supposed to know how to convert meters to millimeters to centimeters, but here it does it for us. So our 2 millimeters is 0.002 meters. Index of refraction, We're going to put this on a 2 base curve. We're going to say it's a vertex distance of, say, just a random 13. And we're going to make this a -2. And if we factor all those in, it turns out that the power factor, it's a minus lens. And if this is a minus lens, obviously it's going to minify. And it's going to minify at a -2, about negative 2.53%. But we have to factor in the component of its thickness, its index, its base curve, its vertex. I'm sorry, well, the ones that for shape factor, index, thickness, and the base curve. That's going to affect. So we're actually going to have a little bit of a difference in magnification. But if we multiply the shape factor times the power factor, we're still going to have a minification of this -2 lens as the patient is seeing. So let's just say you had two base curve on the front, a 13 vertex distance, and a -2. And it turns out that this makes sense. If I had the same lens with the same index, with the same base curve, with the same vertex, with the same thickness and same vertex power, the amount of difference in magnification, so the right eye would magnify -2.27% and -2.27%, and the difference between right and left obviously would be 0. So here I get to see, here's the properties of the right eye, properties of the left eye, or right lens rather, and left lens, and how much they're going to magnify, and what's the difference. And here's the problem. This is that aniseikonia, the difference in magnification is what we're really looking at. So what happens if this was not a -2 in the right eye, but it was a -4 in the right eye? Instead of a 2 base curve, it was a 1 base curve. And what you'll start to notice is now we're going to start to see how I have the aniso, or anisometropia, of about 2 full diopters. Here, the -4 with the flatter base curve is now going to minify, or the change in magnification is -4.82%. The left eye didn't change, but now there's a difference between the two. And this is the difference. When we're in eyeglass prescriptions, we start to run into problems where if there is too much of a difference, the image size that's going to be projected on the retina, the patient won't be able to fuse the two. They won't be able to use the two. So notice, even right now, 3% is really, I think 2.5%, 3%. This is when we start maybe having trouble in different literature, different studies. It depends on the person, depends on the magnification difference. But for our purposes, let's just say, hey, anything 3 and higher, we're going to use that as a threshold. And this is perilously close to that. What happens if I had a -5? Oops, let's get out of this. Let's say I had a -5 sphere, and I had a -5 in the left and in the right. But one day, a man gets cataract surgery, and they do the cataract surgery, and now they're going to make the left eye, we'll do the cataract surgery in the left eye first, because most of the time the doctors do the left eye first, or one eye first, wait a few weeks and do the other. And this is common for us. So now they make my new guy a plano, and we would not put a plano on a 1 base, we'd probably put on a 6, let's argue. So now, let's go back because I can't. Let's do 0, tab, base curve 6, tab. Make sure we do tab. Because if I overwrite the formula, it won't look good. So if you ever do overwrite something, reload it and start over. So I'm going to put the number in, hit the tab button, number in, tab. So now take a look at this. I still have that, let's say I make a pair of glasses after cataract surgery, and it's still a -5 in the right eye. And we generally put those on flat base curves. And we generally do a plano in the left because that's what the doctor asked, and we would put that on a 6. Well, now they may still see 20/20 out of the right individually with that -5. They may see 20/20 out of the plano in the left individually, but now we have a huge problem. I don't see well because there's almost 7% difference in magnification. That eye's not going to be able to fuse. That's looking centrally. There's going to be a different image size. Don't get me started. We've already talked about if you look up, down, left, right away from the optical center, there's going to be different prismatic effects, especially if we look down through, say, a line bifocal. Well, that's when we start getting our calculation of slab off that you've covered in other classes, so we can work on that as well. So now, let's say we have the exact same thing. So we're going to have 8, -5, good, there's -5, 8, and now 2, Now, the way I've set this up is we can play the first one is pair number one, and I can sort of see there's a 6.79%, but now let's start playing with the numbers. And what I mean by that is, what can I do to the indices, the index of refraction, the thickness, the base curve, the vertex distance? I can't touch the back vertex power. The doctor wants a -5 on the right, they want a plane on the left. I can't change those, so we're not going to change the power to change the magnification. Well, let's start working on this. What happens if I took, and instead of having a super flat base curve for that -5, let's make that more a steeper base curve. And all of a sudden we went from a -5.95% magnification to a -535. Well, the difference is a little bit less. What happens if I made this a high index? Let's make it a poly for now. Now, it doesn't affect it as much, but there it is. I bring the vertex distance in a little bit, and obviously you got to watch out for the change in vertex because it may change the effective power, but be that as a mag. Let's make this a thinner 1.0. Actually, let's do, want to magnify more for this one, so let's make it 3.5. And now let's see if I can get this plano, and let's make it 1. So in a nutshell, if I make it thicker, more magnification. If I lower the index, more magnification. If I increase the base curve, more magnification. And if I change the vertex, that depends if it's a plus or a minus. But notice how I went from a -595 to a -439. Look, by changing some of the components of this, I've changed the level of minification. Notice how I still have, I changed the vertex, fair enough. But notice what I did by changing the base curve and the index and the thickness. By how I shaped the lens, what the shape of the lens is, I actually added a little bit more magnification to make it so it's not minifying as much as the rest. Well, let's work on this one. This is my thickness. Let's make this a 1.0. Let's do it. Now, what we used to do is we used to swap the base curves. And what I mean by that is the flatter lens would go on the more minus lens would go on a flatter base curve. And generally, the more plus lens would go on a steeper base curve. But if you do what we used to say, just swap the base curves. In this plano, let's put it on a 2. And notice how when it was on a 6 base, the difference was 4.77%. But if I put it in a 2 base curve, now we're down to 4.5%. And if I made this a 9 base curve, and let's just play around with these a little bit. Higher thickness, let's do 4.5. A lot of these are unreasonable, but we're trying to show you sort of the difference. So now, if you take a look at, we've increased the thickness, lowered the index of refraction, increased the base curve. Let's make this. Okay. Well, for the plano, it really don't matter, but be that as it may. Now what we've done is I want you to take by manipulating these numbers, up in thickness, down in index, up in base curve, the vertex distance by making it closer. 1, 2, 3, 4. We've gone from -5.98% magnification to only -2.12. And now we went from decrease the thickness, increase the index, decrease the base curve. And again, the vertex didn't make a difference because it's a plano, but you get the idea. And we went from a difference in -6.79% to only -2.23%. So we wanted to try to get this somewhere in the neighborhood of 3% different between right and left. We've accomplished this. Now, herein lies the problem. And that is, that may be unreasonable. Putting a -5 on a -9 is such a stretch because we want on a 1. Changing it too much may impact the optics of the lens because now we're going to have more oblique astigmatism. We're going to have less of an optimal performance. So there's a balancing act. What are we going to do to try to keep this number at less than it was? And what is acceptable to minimize the difference in magnification while still keeping close enough to the base curve that they're not going to have such the degradation of the optical properties of that lens. It's not so far off from the base curve that it feels like they're more in the fishbowl. And this is sort of the balancing act. And maybe there's such a huge amount of aniso that you can't find a good balance. But again, for the academic exercises for us, the idea on this particular exercise is I want to have you enter a prescription with specific properties of this lens. And then I want you to develop with the exact same prescription as pair one, but I want you to start playing with the numbers. And again, what do we have to do by changing them? What aspects of changing the property of the lens, not the power, but the property of the lens, will affect the magnification, and how do we minimize the difference between the two to make sure that that aniseikonia, or the result of the difference in prescription between right and left eye, or the aniseikonia, or the resultant difference in the image size that the patient experiences, is limited, because this -6, almost 7 degrees, 7% different may be a big deal. This -3 may be a little bit more acceptable. So this is what this whole thing is. And again, worst comes to worst, you just close it, you reopen it, and start over. Just don't overwrite it. That's why I'll give you a copy, but it's not in the central area. Don't you go. But again, that's how this template works. And again, in the take home, what I wanted us to sort of get from this exercise was, it's not just the power that affects magnification. It's how do we make the lens? And now, if how we make the lens affects the magnification, how can we manipulate it? How can we change it? And if we have a patient that has too much anisometropia, that it affects their vision right and left with two different image sizes on the retina, and they're not able to fuse the two, what can we do with lens design? What properties can we change, and how can we change them to try to minimize that difference? And that's it in a nutshell. So have fun. We'll give you some exercises to play with. And I think that's it for this one. Talk to you guys in a bit. Be good.